All right, welcome back. This is part two of Introduction to Microsoft SQL Server. Still remain myself, Ade. Friends call me Ade's DBA, and this bootcamp is powered by Await Services. So in part one, we looked at the evolution of SQL Server and the different versions from year 2008 up until year 2022, the different editions we have as well as the different features that each version has brought to the clients. We also explored the SQL Server Configuration Manager as well as the SQL Server Management Studio. So right now, we're going to talk about databases and database objects in general. So inside of SQL Server, we store data in the database. Okay, and every database has two files, a transaction file or transaction log file and a data file. The extension of the transaction log file is .ldf, while for data file, if it's a primary data file, it is .mdf, and if you have multiple or other files, those are secondary files, and those will have the extension of .ndf. So for transaction log file, whether it's primary, whether you have one or multiple, all of them will have the same extension, which is .ldf. But for data file, if you have multiple data files, one of them, which is the primary, would have .mdf, while the others will be .ndf. Okay, that's another typical interview questions right there. So what is the difference between a transaction log file and a data file? So transaction log files contain transactions that go on in the database, inserting of data, removing of data, deleting data, truncation of data, and then updating existing data. All these are transactions that go on in the database. So the log file will contain all these transactions. Okay, and this is necessary in case we need to, recover to a point in time, or we need to roll back something that has been done. Rollback is just like when you undo what you did earlier. So, but these transactions, once you take a backup of the transaction log, these transactions will get flushed into the data file, and then they will become the actual data. So in real life, think of the transaction log file as the bank statement or the account statement. On the account statement, you will see, that you withdrew this amount of money this day, on this day, and so time, this money was deposited. All those different transactions, you will see them. So those transactions, that the bank statement is similar to log file, but the data file will give you the final summary of what you have in your account. So in that example, a data file is just like your account balance. After the depositing and withdrawal and everything, how much is left? That is the data file. So after deleting, updating, truncating, insertion of data, then what data is left in the database? That is what you have in the data file. Okay, so the log file is similar to the bank statement in that it has all the transactions that you do on your account, the withdrawal, the deposition, and all those things. While the data file is similar to just your account balance. You check your account, that's the summary of everything. Okay. So when you now back up your transaction log file, which we'll talk about backup later, when you back up your transaction log file, these transactions will get flushed with the data file, and at this point you cannot roll back again because these transactions have been committed. Once you commission of date of a transaction is similar to saving the transaction or is saving something. On Microsoft Word, when you type, you say Control S, and that is it. There's no way you can Control Z again after you've Control S because it's been saved. But if you have not saved, you can do Control Z to roll back to undo it. Okay, so after these transactions are flushed to the data file, they cannot be rolled back anymore. So a data file will contain the data, okay, which is like the summary of all the transactions that have happened in the database. It contains the data and it also has other objects, such as tables, indexes, views, stored procedures, triggers. All these other objects are present in the data file together with the data, the actual data itself. So physically, when we are looking at SQL Server on the screen, we will see that the data are stored in tables. We're going to see that when we do the demo. They are stored in tables. But internally, inside of SQL Server, these data are actually stored on data pages. Okay? They are stored on data pages in the data file. But when we are looking at it physically, they are stored on tables. So a data page inside of SQL Server is 8 kilobytes in size. This is another typical interview question. A data page, think of a data page like an A4 paper, like a plain paper that we use to write stuff or print. So it's 8 kilobytes in size. While we have an extent is a combination of data pages, a combination of 8 data pages. And the size of that, of course, 8 by 8 will give you 64 kilobytes in size. So you can be asked in an interview, what is the difference between a data page and an extent? So a data page is 8 kilobytes in size, while an extent is 8 data pages, which is 64 kilobytes in size. Okay. So broadly speaking, we have two types of databases. We have the system databases. We also have the user databases. Okay. So the system databases, they come pre-created or pre-installed with SQL Server. Once you install SQL Server, automatically you have all the system databases because they are actually necessary for the SQL Server to run. Okay, they're necessary for the SQL Server to start up and function properly. But while user databases, these are databases that we create as humans, as users of SQL Server. We create these ourselves. They don't come with SQL Server. So, and on the right here, see, here we have databases. So if you expand this, then you will see system databases, and these are system databases that we can see on the Object Explorer of the SQL Server Management Studio. So we have the master, we have the model, we have MSDB, and we have TempDB. These are the 4 system databases that we can see on the Management Studio. So, but down here, let me change the color. Here, this is another database. But this is not a system database. As you can see that this does not belong in this folder here. It's not here. So this is a user database because this was created by me. It didn't come pre-created or installed in SQL Server. While all these ones came with SQL Server, I did not create these ones. So these are system databases. Okay, and when a user creates a database, you can pretty much give it any name. You can pretty much give it any name that you like. Okay, so let's move on. So now let's explore these system databases one after the other. So the master database, this is like the brain of the instance. This is the brain of the instance because it is in this database that we have system level information. And all this information, they are necessary for SQL Server to start and also continue running. All the logins, if you are doing encryption, the certificate, everything, they are in the master database. Everything needed for SQL Server to start up and also run and also that has to do with connection. And all this information, they are stored in the master database. So it's like the brain of the instance. If the master database is corrupt, there's no way you can connect to the database engine. Okay. So next is the model database. So as the name implies, is the model is like a template for other user databases. So whatever configuration that the model DB has, that is the same configuration that any user database would have. So it is a template for other databases that will be created on the SQL Server instance. So if you want your user databases to have a particular configuration, that means you have to modify that configuration on the model because it is the template that the other databases would follow. So the MSDB now. MSDB, this is a system database that keeps history of processes, that are going on in the inside of SQL Server. It keeps history of processes, jobs history, and it is heavily used by SQL Server agents. And as we know, SQL Server agent is responsible for running scheduled jobs and also alerts, also sending out alerts and all that. So MSDB is highly used by SQL Server agent, and then inside of MSDB you will see a lot of history of the processes going on inside of SQL Server. So then the next one is TempDB. So like the name implies, temp means temporary. So this is a workspace that we use to keep temporary objects. Okay, if we don't need an object permanently, this object, for example, a temp table, they are saved in TempDB. And TempDB is very, very critical to the function of proper functioning of SQL Server, because apart from keeping temporary objects like this, it is also a workspace for a memory workspace. So if the memory on the server is not enough, TempDB is a workspace that SQL Server uses to get additional space or memory for operations like index rebuild, join, sorting, and some other operations that we carry out inside of SQL Server. So it is very, very important. All the system databases are actually important. Then the fifth system database that is not visible on the Management Studio is called the resource. The resource is a read-only system database, and it contains system objects, but you cannot see it on Management Studio. It's inside the file. You cannot see it on the Management Studio. So these are the system databases. So if you are ever asked in an interview, what are the system databases? It is not enough to mention them, but also say one or two things about them. And of course, to distinguish yourself from other candidates, go ahead and mention the fifth one, which is not visible on the Management Studio, and that is the resource. That will make you stand out amongst the other candidates. We are going to see all these databases in detail when we get to the demo session. So now let's talk about server environments. In any company, we have two broad environments. We have the lower or the pre-prod environment, and then we have the higher or the prod environment. So an environment is just like a group of servers that we use for a particular purpose. So when we say pre-prod, these are servers that the SQL Server installed on them are not connected to client-facing applications. They are not connected to the external world. They are just used within the company for development, testing, staging, and quality assurance purposes. Okay, so they are not connected to the outside world. It's just within the company. So they are called lower environment or pre-prod. While the prod environment, these are servers that we used for production. So these are servers that we install SQL Server on, and this SQL Server is connected to client-facing applications. For example, the popular social media that we use, let's say Facebook, there's a database connected to it. So because we are external users, you know, I don't work for Facebook, so we are external users in terms of Facebook as a company. So that application is client facing to me. So and whatever database that is connected to that database is on the prod environment, or is on the prod server, or the production server. But the servers that are used within Facebook to develop applications and test queries and all that, those are prod environments. We that are external to Facebook, we don't have access to them. Okay, so these are the two broad environments you will see in any company. And for the prod environment is just production servers generally, but for the pre-prod there are varieties. So we call some servers development servers, or we can call them dev servers. They are basically servers that are used for developing queries. So if you want to write some queries, you write them on the development servers to test, because you're coming up with an idea. Okay, and we also have test servers. These are servers that are used to test a query or queries that are already developed to see if we meet some certain standards, based on what customer wants or the business need. And test servers are also known as UAT, and UAT stands for user acceptance testing. Okay, user acceptance test. That's meaning of UAT. Then we also have other lower or pre-prod environments such as staging and QA. QA means quality assurance. Okay, so there are different companies use different names. Some companies have just dev, UAT, dev and UAT. Then, of course, prod. While some companies have dev, UAT, staging, and QA, and then prod. So it varies like that. But of course, every company has prod, but not every company has these ones. Some companies don't have pre-prod, which is not good, but there are companies without pre-prod, they just have prod. So it is recommended to have pre-prod, have at least dev. So this will give you an environment to test all kinds of things. Because if anything breaks, your external customers are not affected in any way. If something bad happens on that server due to, from testing and all that, because it's not connected to the client-facing application, so the external customers will not feel anything. So that's the benefit of this pre-prod environment. You can do all kinds of stuff. Do some loading to test. If there's a high workload on the server, will it break or not, and all that. So even if it eventually breaks, the clients will not feel anything. But we don't do such thing on prod. For before queries or applications will go to prod, they must have gone through this process. Well tested, well developed, well tested. Make sure that everything meets the expectation of the client before they will now get deployed. So the process through which a query would go from pre-prod to prod is called deployment. So from pre-prod to prod is called deployment. So if a query is developed in the pre-prod environment, they will test it, they will do, they will stage it, they will do all kinds of things, they will do quality assurance. If it meets all the requirements, then this query would then be deployed to production. That is when it will now get on the production servers, because it's been tested and trusted that it will not affect anything on the production servers, such that the external client will now start complaining about. Okay. All right. So please get used to all these technical terms because this is what they use in the real world out there. Pre-prod, prod. Sometimes they call them lower environments, dev, UAT, staging, QA. So there's some companies have different servers for all of these. Some companies just have servers for some of them. So it depends on whatever company you work with. So now let's go do some demo to see these system databases and see user databases, how they are created, um, and see how all these things work together. So I'm going to pull up my lab. We don't need the configuration manager anymore, so I can minimize that. So this is my management studio. Let me expand the databases. Let me expand the master system databases. So we saw this earlier in part one. So the master database, I told you that physically data is stored in tables, right? But internally it's stored on data pages. So physically what we'll see is tables here. See? Tables. Then we see views. There are a lot of data on these tables, views. Then when you come to programmability, you see stored procedures. When you come to security, this is where we manage access to the database. Okay, this is where we manage access to database. So let me expand each of these. So here, see, we have system tables and external tables. Yeah. And you can also create a user table. You can create some tables here as a user. See, so if you right click on tables, you come to new, you can create a table here. But usually we don't mess with master database. We don't want to create any table in the master database. Okay. You open this. This came with SQL Server installed. All these tables, they have some information that SQL Server uses. So if you want to see the content or the data in this table, so click on any of the table, right click, and go to select, select top 100 rows. I'll give you some time. Bam. And this is the data. This is the data in that table. See, this is everything you have in that table. So let's try another one. Right click, select top. This one does not have anything. Come here, right click, select top. And this one has just one record. Yeah. So that's that. Then views. We'll talk more about views later. So views are just like virtual tables. So there's an important schema in SQL Server known as the information schema. So schema is like a framework. Okay, so like a framework. So it's an important schema known as information schema that you can get a lot of information from in terms of how many columns are in a table, how many domains, how many parameters, how many routines, and many tables are in a database, and how many views and stuff like that. So basically, the hierarchy of things in SQL Server is what you see here. See here, the hierarchy is this first one is the name of the database. The next one is the schema. Then this one is the table. This is where the data is stored. So on a particular instance, remember we can have multiple databases. Now let me go back. On a particular server or virtual machine, we can have multiple instances, up to 50. Okay. Then on one instance, you can have multiple databases. Then in one database, you can have multiple schemas. And then in one schema, you can have multiple tables. So that's the hierarchy. Okay, that's the hierarchy. But for the most part, this is what you're going to be using, these three. Database dot schema dot table. So once you see this dot notation, you see three, so you know that the first one is database, the second one is schema, and then the last one is the table. But if you see two, in case you see something like this, dbo dot spt, blah, blah, blah. If you see two, then you know that this one is schema, this is table. But if you see only one, then you know that this is just table. Okay. So this query, this same query, can be written as this. You can remove this master, then it becomes two, hierarchy or two levels here. So I've removed the database. So this is now schema does. So if I run this by clicking execute, it would still run successfully. So, and if I can also remove this, and if you see one from in the from clause, then you know that this is just the table. So it's either you have database.schema.table, or you have just schema.table, or you have just table in the from clause, because this is where you are getting the data from. That's why it has from. This data you're seeing is coming from here. Okay. So let's see here. Right click. See, this will tell you this is the table catalog. This is more like the database, the schema, and the default schema. The default schema in SQL Server is DBO. The default schema is DBO. Another typical interview question. What is the default schema? Oh God, why am I typing? What is the default schema in SQL Server? It is what? DBO. And what does DBO stand for? DBO stands for database owner. That's the meaning of DBO. So the default schema is DBO. Okay. But you can also create your own schema. You can create a schema. So there's another schema here. This is information schema, because it's in between database. It's in between the master database and the columns table. So this is a schema right here. But this is not the default. Okay, the default schema in SQL Server is DBO. All right. So when you come to programmability, don't worry about synonyms. You see all sort of things here. If you remember, the version where we have programmability was 2008 R2. In 2008 R2, that was when we started having programmability. So let me go back to the slide. Oh, sorry, it's 2008, not R2. Here. This is when we started having programmability in SQL Server. Prior to that, there was no programmability. So this programmability is what they're talking about. This program is what they're talking about. So in programmability, you can have stored procedures, functions, extended stored procedure, database trigger, assembly, all kinds of stuff here. We're going to talk about some of this, but not all of them. We're going to talk about stored procedure for sure, functions for sure, maybe touch on triggers. Remember, I told you that you can create triggers at the server level, and you can also create triggers at the database level. So anything you create at the database at the server level will affect all the databases in that instance. But anything you create at the database level will only affect that database. Because remember, you can have multiple databases on one server or instance. So this is a server. This is also an instance. But remember that we can have other instances on this same server. But for now, we only have one instance on this server. But it is possible to have multiple. Okay. So how do you differentiate? We already established how to differentiate the default instance from the named instance on Configuration Manager. But on the Audit Explorer, how do you differentiate that? So let me show you, even though we don't have it. So when you connect, if you look at the name of the connection, if it's just a name like this, which is usually the name of the server, then this is a default instance. But let's say you connect and you see something like VM02, sorry, I capitalize VM02 backslash waits. So when you see something like this after connecting, you see, the normal SQL Server. I'm trying to write what is up there. 13, 0, blah 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 blah. If you connect and if you see something like this in the name, then this is a named instance. You can see that this is different from this. Once you see a backslash, okay, you see a backslash in the name of the connection or in the name of the instance, then that instance is what? A named instance. Once you see a backslash, in the name of an instance on the Internet Explorer, then that instance is a named instance. There's no B here, sorry. But if there's no backslash, just like here, there's no backslash in the name. It's just VM02. Then this is a what? This is a default. Sorry, my brain is faster than my fingers. So this is a default instance. But if you see a backslash, then it is a named instance. So that's how you know on the Object Explorer. But on the configuration manager, the default instance will have MS SQL Server, while the named instance will have awaits. Okay, we'll have await or whatever name was given. Okay, all right. So that is that about. Okay, let's see the other databases. So if you come to model, you see pretty much the same structure: table, views, synonyms, programmability, storage, security, and all that. So if you come to security, you see users. Users, whoever is here, are the people that have the permission to connect to this database. Okay, and you see roles. If I open these roles, so there are database roles. These roles are the roles that will give you permission at the database level. Remember, you also have server roles. Okay, so if you come to security, see, let me expand this a little bit. So at the server level, we have server roles, and at the database level, we have database roles. So these roles here will give you permission to do some stuff at the database level, while here we give you permission to do some stuff at the server level. And if you have a server role, that role applies to all the databases on that server or that instance. But if you have a database role, it only applies to that specific database. Okay, all right. So that is that. Don't worry yourself too much about all of these. These are basically when you're doing encryption, and all the other stuff. Okay. So this, like I said earlier, as the model database is the template. So whatever configuration it has, that is what will be the configuration of any user database that we create. So if you right click, if you want to see the configuration, right click on it, go to properties, come to files. See, these are part of the configuration of this database. For example, the owner is say the size of, so here we have the database files. I mentioned that Every database has two files, right? The data file and the transaction log file. So this first one, this is the data file. And this second one, this is the T log, is also known as transaction log. This is the T log file. Okay. So this is their initial size. This is the configuration. So if I create a new database, it will have the same size for the data file and the log file. This is the auto growth setting. This is how much you want the file to grow in size if this initial size has been exhausted. So let's say I'm inserting data in this table and then I fill up all these 8 megabytes, and definitely it needs to grow more because if I'm still inserting data, so it will grow in size by 64. So 8 plus 64, the next size will now be 8 plus 64, and that will be 72. And here we are saying it should grow unlimitedlessly. So it should not have limit, but there's always a limit, which is the size of your drive. So if you have 500 gigabytes drive, your file cannot go beyond that. Okay, but you can go up to the limit of your drive. But on SQL Server, you are not setting any limit. But it's also possible to put a limit to it. So you can say you don't want it to grow beyond 100 gigabytes. It is possible, and I'm going to show how to do that. So files. So if I expand this, then you will see I want to see the extension. Remember I said data file will have extension of .mdf. See that? MDF. The primary one. The secondary one will have .n for Nancy, NDF. But for log file, either primary or secondary, all of them will have LDF. And this is the path where you can find these files here. Okay, so let's see how we can adjust this. So if you want to adjust this auto growth setting, you just click on this ellipsis button here. See file growth. You can either say you want the file to grow in percentage or you want it to grow in megabytes. It is recommended to use megabytes because percentage is not consistent. 10% of 100 is different from 10% of 1000. But if you use megabytes, 64 megabytes, for example, it will always grow by 64 megabytes every time it auto grows. It will grow by 64. But if you use percentage, it will grow by the percentage of the initial size. For example, if the current size is 100%, as 100 megabytes, and it needs to auto grow, it will grow 10% of, let's say we set it at 10%, it will grow 10% of 100 megabytes, and that is 10 megabytes. So the next time, let's say after a while, the size increases to 1000 megabytes, and it needs to auto grow, it will now grow by 10% of 1000, which is now 100. So initially it grew by 10, now it's growing by 100. So that inconsistency is not good for performance. So it is recommended to use in megabyte because that will always grow by the same amount every time it auto grows. Okay. So here you can limit the file size to a particular value, but if you leave it here, it will continue to auto grow as long as there's space on the drive. Okay, and here we are saving it to the E drive. If you look at the path here, it is going to E drive. Let me show you. See, you're saving the file to E drive here. What I'm showing you here applies to all databases, whether system or user. If you check a database, you will see all these things. So let's say I want to limit this. I'll just come here, and then you can put whatever limit you want. So let's say you want it to stop at, once it auto grows to 100, it will stop, 1000. So when the size increases up to 1000, it will not auto grow again. It will stop because you set the limit. Okay. So the choice depends on the company or the DBA. So, but some people do it just so that you don't want to fill up your drive with your data file or the log file. Okay, so but now these settings that we have here is what any database that we create would also have in terms of the initial size as well as the autogrowth size. Even the path, this path is what, no, sorry, not this path. This path does not apply. There's a different path that they will follow. And I'm going to show you that as well. Then if you come to options, so these also, any database you create will take this. You will have this collation, you will have this recovery model, you will have this compatibility level by default because this is the template. And you will have all this by default. Okay. So but it will not be saved to this path. So to know the path where a user database will be saved to, I'm going to show you now. If you right click, let me collapse all of it. This is an instance, right click on that instance, go to properties, come to database settings. So if you create a user database, this is where those files will be saved to. This is why it's called database default locations. So the data file will come here by default, the log file will come here by default. If you want to back up a database, it will come here by default. Okay. All right. So that's that for MSDB. Okay, let me see something. I want to show you. It's not here. Okay, let's move on. So now MSDB, we said this one keeps history of processes, that are going on the server. This is a new server, so there's not many things going on yet. But if you look at the tables, these tables will tell you, give you an idea of what process, whose history will be kept by MSDB. So let me zoom in. See? So if you are doing backup of your databases, this guy will be keeping the history of the backup media family, the media sets, and all that. Okay? If you are doing automatic seeding, it will keep the history of the automatic seeding. If you are doing log shipping, it will keep the history of the log shipping. What are the primaries? What are the secondaries? What are, all those information will keep everything. We will find them in the MSDB. So if you go down, if you create jobs, see all your jobs, you find them here, their history. See job history, job activity, and all those things, job steps, everything will be here. If you set up mail, you see them here. How many mails you sent out, if there's a queue, and all those things, you will see them here. And then if you create policies, you see all those policies. If you create proxy logins for people with limited permission to do some certain elevated permission that only elevated permission can do, you see them here. So if you have SSIS packages, you also see them here. See packages and all those things. So history basically is what you would find on MSDB. So it is very, very important. And now TempDB, this is temporary, right? So temp tables, come here. If you create a temporary table, you will see it here in the TempDB. But we don't have any temporary table created for now. Okay, come to, there's nothing in the view, so they pretty much have the same file hierarchy. But one thing that you should know about TempDB, apart from the fact that it stores temporary objects, and is used to do as a workspace by SQL Server when you are doing doing join or sorting or index review, is that every time you restart SQL Server, Everything in the temp DB will get deleted, and then it will regenerate itself all over again. Okay, so everything will get deleted and then it will regenerate itself. That's why it's called temp DB. Nothing in there stays permanently. Okay, it will erase everything and regenerate itself. So now let's move to user database. So if you see, they have pretty much the same hierarchy, except for the fact that this one has database diagrams, but the TempDB does not have database diagrams. But every other thing is pretty much the same. This one has temporary tables. This one does not have. So, but if you look at tables, views, synonym, programmability, service, storage, you have pretty much the same thing. So, and these are system. This is a user database. But they have pretty much the same structure, but of course, different functionalities. Okay. So if I save data in this database, they will be in a user table. So these are system tables. All of these become pre-created in SQL Server. But let's say I want to create a table. I'll just come to tables, right click new, create a table, and if I want to insert data, it will go into that table. Okay. So now let's compare the configuration of this database to the master, because I created this. But let me erase this and no, that's not what I wanted to do. And to drop or delete the database and create it again. Close existing connection. So if you want to create a user database now, these ones are already existing. Okay. But let's say you want to create a user, come to databases, right click, new database. See, all these settings that I showed you earlier, they came from the model system database. Initial size, auto growth. But remember I told you that this one will not come from model. This one will go to the database setting that I showed you earlier. So this one is coming from model. Then if you come to options, all of these are coming from you. All of these are coming from the model database, all of these. Okay. So, but you have the opportunity to change them if you want while you are creating the database. So I can decide to change the recovery model from full to bucket if I want. But by default, it will take all the configuration from the model. Okay. All right. So I think we've explored the system databases and a user database. I don't know if there's anything that. Yeah, for now, that's it. Let me go back to the slide, see if there's anything. Yeah, you don't see server environment on Management Studio. These are just servers that companies will designate as they deem fit. But this is not available on Management Studio. Okay, these are just servers, computers. You can decide to say, so for example now, I can decide that my VM01 will be my prod server if I have VM01, but I don't have that yet. So I can decide that VM01 will be my production server. I can say VM02 will be my development server, and VM03 will be my test server. So it's just a designation within the company. So what that means is that VM01, which is my production server, will be the only server that will connect to a client-facing application. All the other ones will be in-house, will be internal to the company. Okay, such that anything we do on them will not affect the external clients. But anything we do on production server would affect the external clients because production server is connected to the client-facing application. That's why only limited people have access to production servers. For the most part, the DBA, and if anyone apart from the DBA need access to production server, they will have limited access, limited permission, because you don't want them to mess things up so that the external client will not be complaining. So that's about it for the demo. So if you want to read more about everything we've talked about in this introduction to Microsoft SQL Server, there are some links here for additional study. Feel free to click on this link. I'm going to upload a PDF of this. I'm going to upload a PDF of this so that you can, click on this link and it will take you to the web page. And of course, feel free to contact us if you have any questions or contributions or concerns via email admin@awayservices.com or through phone. Use these. Our website, you can use this as well to reach us. Thank you.